Swan R2, a weird green comet, has just shown up out of nowhere. Astronomers thought it would be just another icy rock passing by, but what they're seeing instead has them worried. It's unpredictable. It's brighter than expected, and nobody's sure what it's going to do next. Could Swan 2 be hiding something dangerous? The sudden discovery. On September 11, 2025, astronomers noticed something unusual in the data from SOHO. The Solar and Heliospheric Observatory, SOHO, spends its time watching the Sun, and one of its cameras, called Swan, maps the solar wind as it flows through space. It wasn't designed to hunt for comets, but on that day, it picked up a faint blur that didn't belong. At first glance, it looked like noise on the screen, just another speck among thousands of stars. But this speck moved, and with each passing frame, it carried the thin trace of a tail. The discovery was credited to Vladimir Bazugi, who carefully reviewed Swan's scans and realized this wasn't an error. It was a comet, a brand new one, hiding right next to the Sun's glare. The official name came quickly. See 2025 R2 Swan. For most people, that's just a catalog code, but for astronomers, it meant something extraordinary. A comet that had slipped into our skies without warning. What made this more surprising was the timing. By the day it was spotted, Swan R2 was already just about to reach its closest point to the Sun. That explained why it suddenly flared into view. As the heat hit, frozen gas and dust exploded off its surface, creating a glowing coma that finally made it visible to instruments. In reality, it had probably been active for weeks. We just hadn't seen it. When the first report spread, telescopes scrambled to catch it. The thought was unsettling. This comet wasn't predicted. It wasn't tracked for years in advance. It simply appeared already in full swing, as if it had been waiting in the sunlight to reveal itself. And that led to the first big question. If it could sneak up on us like this, what else was hiding out there? The Phantom Traveler. For most of us, Swan R2's story began the moment SOHO's Swan instrument picked it up. But the truth is, this comet had been out there long before that first official sighting. Once astronomers knew where to look, they started digging through earlier sky images. And sure enough, faint traces of it appeared in data from August 20th to 25th. It was already active, already shedding material, but hidden so close to the Sun that nobody on Earth had a chance of seeing it. By the time it finally revealed itself, it had already traveled millions of kilometers into the inner solar system. That raised an even bigger question. Where had it been before that? The orbit gives us some clues. Swan R2 isn't a short-period comet like HAL's, which loops back every 76 years. Its path is stretched out to extremes. The current best estimates put its orbit at more than 22,000 years long. Think about that. The last time this object came anywhere near the Sun, human beings were still painting on cave wall. Other models suggest it might be shorter, maybe just a few centuries. But either way, it's not a regular visitor. It spends almost its entire life in the frozen outskirts of the solar system, where sunlight is so weak, it can barely reach. That's why it looks and behaves the way it does. Out there, it sat in deep freeze for ages, storing gases and dust from the earliest days of the solar system. Now, as it swings in close, that ancient material is bursting free for the first time in thousands of years. It makes Swan R2 feel less like a new discovery and more like a messenger from a forgotten time. And the more astronomers studied its path, the more they realized something remarkable. This comet didn't just slip quietly into our sky. It was on a trajectory that would bring it surprisingly close to Earth into the furnace. By the time Swan R2 was discovered, it was already in the middle of a dangerous stunt. On September 12, just one day after the world first learned its name, the comet swung to within half the distance between Earth and the Sun, about 75 million kilometers from the solar furnace. For a fragile ball of ice and dust, that's a brutal test. The sunlight at that distance is strong enough to tear a comet apart, and many don't survive the heat. Swan R2 though seemed to thrive. As it rounded the Sun, its surface began to crack and vent. Jets of gas shot out, carrying clouds of dust with them. The coma, that glowing halo around the nucleus, expanded and brightened, turning the comet into something far easier to spot. And trailing behind it, the tail stretched out like a cosmic banner, pointing directly away from the sun. Some observers even reported hints of green in the coma, a color often caused by gases like diatomic carbon when they're blasted by sunlight. To anyone watching, it was like the comet had been invisible one day and alive the next. This sudden transformation is part of what makes comets so dramatic. They can spend thousands of years frozen and silent, then flare up in weeks as they dive toward the sun. It's a performance written by physics, but it plays out like a show. For astronomers, this was the moment Swan R2 became truly valuable. With every outburst of gas and dust, the comet was giving up clues about what it's made of, what it carries inside, and where it might have formed. For casual skywatchers, it was the moment the comet became more than just a line in a catalog. It was visible, active, alive. But Swan R2 wasn't finished yet. Having survived its brush with the sun, it was now headed on a path that would bring it closer to Earth than most comets ever dare. The long orbit's secret. Every comet carries a kind of map in its orbit, a record of where it came from and where it's going. For Swan R2, that map is both impressive and uncertain. The numbers suggest it doesn't belong to the family of comets we see every few decades. Its orbit is stretched so wide that it may take more than 22,000 years to complete a single trip around the sun. That would mean the last time it swung by, humans hadn't yet built the pyramids in Egypt. Our ancestors were still hunting and gathering while this same comet was carving its last path through the inner solar system. But here's the catch. Astronomers only got their first look at Swan R2 a short time ago. That means its orbit is calculated from a limited slice of data. With comets like this, the numbers can shift as more observations come in. Some solutions suggest it might come back in just a few centuries. Others lean toward the thousands of years scenario. Either way, Swan R2 is not a frequent visitor. It spends nearly all its life on the far edges of the solar system in the kind of deep freeze where sunlight is just a pale glow. That background explains why Swan 2 looks so fresh. It hasn't been baked by the sun over and over like Hall's Comet or other regular returners. The ices inside it are ancient, preserved from the time the solar system was still forming. Every burst of gas we see now is a piece of that early history escaping into space. So, while its orbit still carries uncertainties, one thing is clear. This is not just another routine comet. It's a messenger from the frozen outskirts pulled in after thousands of years away. And after skimming the sun, its path was about to carry it closer to Earth than anyone expected, rushing past our world. By mid-October 2025, Swan R2 had finished its dance around the sun and was heading outwards again, but not before passing uncomfortably close to Earth's orbit. On October 20th, it was set to come within about 39 million kilometers of us, roughly 100 times farther than the Moon. In cosmic terms, that's practically a handshake. Comets have soared much closer, but for a body this large and this fresh, the distance felt tight enough to capture attention. Astronomers pointed out another key detail. Just weeks before that closest pass, Earth would actually cut across part of Swan R2's debris stream. Around October 5, our planet would slide through the trail of dust and particles the comet had been shedding as it rounded the sun. Encounters like this are the recipe for meteor showers. If the debris was thick enough, it could mean a new burst of shooting stars lighting up the night sky. Nobody could be sure. Comet dust trails are unpredictable. Some years they deliver a storm, other times nothing at all. Still, the possibility was enough to spark excitement among skywatchers worldwide. Even without a meteor display, the approach itself was thrilling. From our perspective, Swan R2 would climb higher into the night sky, moving away from the sun's glare and into constellations easier to spot. Southern Hemisphere observers had the best seats at first. But as October went on, northern skies began to catch their share of the view. Through binoculars, the comet's coma looked like a faint green fuzzball with its tail stretching outward against the star. Moments like this always remind people of how fragile Earth's place really is. We orbit the sun alongside countless comets, most of them invisible, some of them potential hazards. Swan R2 was no threat, but its passage felt like a reminder. A cosmic neighbor had come close enough to notice, leaving us to wonder how many more are still waiting their turn. The sky's green visitor. Seeing Swan 2 wasn't as simple as stepping outside and looking up. Comets don't shine like stars. Their light is spread out, soft and hazy. So even when they're technically bright enough, they can still be tricky to spot with the naked eye. Early on, binoculars or a small telescope were the best tools for catching it. To those who managed, Swan R2 looked like a pale green smudge in the dark, its coma glowing softly and its tail stretching away like a faint brush stroke across the sky. That green glow came from gases released as the comet's surface boil. Molecules like diatomic carbon fuse when sunlight hits them, giving many comets their eerie tint. It's a color you can't mistake. Faint, otherworldly, almost like a lantern shining underwater. Photographs taken by amateur astronomers captured the effect beautifully, showing Swan R2 as a ghostly orb with a tail that in some shots spans several degrees of the sky. To put that in perspective, a full moon covers about half a degree. The comet's tail could be 10 times longer than that, though faint it took long exposures to reveal. Observers in the southern hemisphere had the advantage in the first weeks, with the comet hanging low in their pre-dawn skies, but by late October, as it pulled away from the sun, it crept into darker evening skies, visible to more people in the north. Star charts showed its path threading through constellations, a moving visitor against the fixed patterns. For backyard stargazers, it became a challenge and a reward tracking it night after night, watching it drift against familiar stars. Even for those who couldn't see it directly, the images told the story. Swan R2 wasn't a blazing spectacle like Hal's comet in 1910 or Hale-Bopp in the 1990s. It was more subtle, more elusive. But that's part of what made it special. You had to look carefully, patiently to notice it. And once you did, it felt like you were peeking at something ancient, slipping quietly through the night. Part of a cosmic family, Swan may second feel like a one-of-a-kind visitor, but it's also part of a much larger family. Comets have been stirring wonder and fear for as long as people have looked up at the sky. The ancient Chinese called them broom stars, believing they swept change across the world. In medieval Europe, they were thought of as omens, often linked with war or disaster. Even in more recent centuries, comets have left lasting marks on culture. In 1910, people bought comet pills because they feared poisonous gas in Hal's tail. That mix of awe and fear has always followed these icy wanderers. In modern times, comets have become windows into the past. Each one carries material from the earliest days of the solar system. Hal's comet returns every 76 years, a familiar guest. Hale-Bopp, which lit up skies in the 1990s, became a worldwide spectacle. Then there are the rare and dramatic stories like Shoemaker-Levy 9, which broke apart and smashed into Jupiter in 1994, leaving scars bigger than Earth on the giant planet's atmosphere. Those collisions show just how powerful comets can be. And then there are the interstellar travelers, outsiders like 2I Boris and 3I Atlas. Boris was the first confirmed comet from another star system, flying through hours before disappearing forever. Atlas was massive, brighter, and stranger than expected, raising questions about what kind of object it really was. Against those headlines, Swan R2 might seem quieter. It's not interstellar, and it didn't put on a once-in-a-century light show, but it's still unusual. Its long uncertain orbit and fresh composition make it different from the comets we usually see. What ties them all together is their role as messengers. Each comet is like a delivery from deep time, carrying frozen material older than human civilization. Swan R2 may not become a household name, but for scientists and skywatchers, it belongs in the same conversation. Another reminder that our skies are never truly empty. What lies inside Swan R2? At its core, a comet like Swan R2 is nothing more than a frozen chunk of rock, dust, and ice. But what makes it fascinating is exactly what those ices are. Locked inside a simple molecule: water, carbon dioxide, carbon monoxide, and methane. The same ingredients that floated around in the solar system 4.5 billion years ago. Some of those molecules break apart under sunlight and create new gases like cyanogen and diatomic carbon, which glow green when energized. That's the strange light that makes Swan R2 look like a ghost in the night sky. Every time the comet heated up near the sun, jets of gas burst from its surface. These jets carried dust with them, spraying it into space to form the long tail we see from Earth. Sometimes the outbursts are gentle, like a steady leak. Other times they can be violent, splitting off chunks of the surface and sending sudden clouds of material into the coma. That unpredictability is part of why comets are so carefully studied. Each one reacts to sunlight differently depending on how it's built. Swan R2's composition is valuable because it hasn't been baked by repeated close passes to the Sun. Many comets lose their outer layers over time, leaving behind crusty shells that reveal less about the early solar system. But Swan R2 is a newcomer to our skies. Its interior still rich with pristine ices. To scientists, that makes it a time capsule, a preserved sample of the raw material that once went into building planets, including Earth. And there's something humbling about that. When you look at Swan R2 through binoculars or in a photograph, you're not just seeing a comet. You're seeing pieces of the ancient solar system finally breaking free. Molecules that have been frozen for tens of thousands of years finally glowing in the warmth of the sun. It's a reminder that our planet, our oceans, even life itself may owe its beginnings to messengers like this. When comets get too close. For all their beauty, comets carry a reputation that goes far beyond glowing tails and pretty photographs. History shows what can happen when space rocks, icy or not, come too close to Earth. The most famous example is Chicxulub, the impact 66 million years ago that wiped out the dinosaur. That wasn't a comet like Swan R2, but it proves the scale of destruction is possible. A more recent event in 1908 flattened over 2,000 square kilometers of Siberian forest near Tunguska. Many scientists believe that was caused by a small comet or asteroid exploding in the atmosphere. Swan R2 was never in line to hit us, but its minimum orbital intersection distance, basically the gap between Earth's path and the comet's, was narrow enough to take notice. About 0.0048 astronomical units. That's around 7 million kilometers. In space, that's a tight squeeze. Comets like this remind us how close the line can be between a harmless flyby and something much more dangerous. That's why agencies all over the world keep watch. NASA, ESA, and many independent observatories track the orbits of comets and asteroids, updating their paths as new data comes in. The goal is simple. Spot them early. Swan R2 slipped into view only weeks before perihelion, hidden in the glare of the sun. That was a lucky break. If its orbit had been different, if it had been headed our way, there would have been little time to react. And that's the tension with comets. They're beautiful, but unpredictable. They can flare, fade, or break apart without warning. They can arrive suddenly, like Swan R2 after spending millennia in the cold. And while this one gave us only a safe passage, it served as a reminder. Earth is moving through a crowded neighborhood. Every comet is another roll of the cosmic dice. What are your thoughts on Swan R2? Let us know in the comments down below. Don't forget to